Greetings programs, Atari here, you there, and welcome to another in our series on Arduino Basics. In our previous lesson, we learned how Arduino can read analog values, no problem, but it has a little bit of trouble writing analog values. And that's because it doesn't have a digital to analog converter. So it kind of fudges the values a little bit by controlling the duty cycle of the output on a particular pin. So what happens is its digital control, its on-off, its binary state, is used to create a square wave, which is a binary wave, full on, full off. And what this on-off pattern does is it sort of simulates all of the various voltages between full on and full off by changing the amount of time that that signal is switched on. So if it's 100% on, it's the full 5 volts, and if it's 100% off, it's 0. And then if it's on for half the time, it's 2.5 volts. Now, the duration of this on time is called the pulse width. Now, to get various analog values, we change or we modulate that pulse width, hence pulse width modulation. If you repeat this on-off pattern fast enough with like an LED, for example, what happens, practically speaking, is that the LED will shine at a particular brightness that's relative to that pulse width. Essentially, what we're doing is we would be turning the LED on and off at such a specified rhythm that it simulates a level of brightness. Make sense? Clear as mud? Yeah, you'll see once we actually wire this thing up. Now for this project, we'll of course be using our Arduino, our breadboard, and our computer. We'll also need a couple of jumper wires, a 220 ohm resistor, and an LED. Now, we have a jumper wire coming out of pin 9, which is an analog out pin, as you can see denoted by the little tilde next to the 9, into the breadboard, into a 220 ohm resistor, into the anode on the LED. The cathode then connects to ground via another jumper wire. Now let's take a look at our Arduino Sketch. Now again, I'm not going to go through all of the code here. I'm only going to go through the pieces that I have not already explained. If you see functions or other commands that you're not familiar with, check some of the previous videos and I'll be able to explain them a little more thoroughly. The analog write command writes an analog value, a pulse width modulation wave, to a pin. It can be used to light an LED at a varying brightness or to drive a motor at various speeds, like if we want to play around with a servo or something like that. After a call to analog write, the pin will generate a steady square wave of the specified duty cycle until the next call to analog write, or a call to digital read or digital write on the same pin. The analog write call is on a scale of 0 to 255, such that analog write 255 requests a 100% duty cycle, as in always on, and analog write 0 is a 0% duty cycle, always off. And an analog write 127 is a 50% duty cycle. Why is it 255? Well, because that's the largest 8-bit number that you can express as a decimal. The analog write command consists of two parts. The pin number, which is the Arduino pin to write to, in this case it's 9 as we defined in the setup, and the value of the duty cycle between 0 and 255, as we also defined earlier. The if statement checks for a condition and executes the following statement or set of statements if that condition is true. These are typically spread across several lines for clarity. and the indentation is also standard for clarity. For more about if-then statements, check out this video or the show notes. Now let's upload the sketch and see it in action. And here we have the completed project. The sketch starts at a 0 brightness, and then on each clock cycle compares the brightness to where it needs to be on the next clock cycle, and then rewrites the analog value plus or minus to determine which way the LED is going to fade. In other words, as it increases in brightness, it writes a longer and longer duty cycle. As it decreases in brightness, it writes a shorter and shorter duty cycle. Now, what happens if we change the delay? Or what happens if we change the fade amount variable? And as a challenge, see if you can figure out how to use a potentiometer to control the fade effect, either through the rate or the brightness. And that will conclude today's Arduino how-to lesson. To learn more about using the Arduino, click the playlist here and watch the entire series. And to get the complete show notes for this episode, including the sketches that are used, click the link right here. If you're interested in goofy electronics projects or learning more about various electronics platforms, click the subscribe button, and don't forget to click the bell notification icon so you don't miss anything. My name is Atari, and until next time, tally ho, y'all.